Hello, you're welcome. Let's quickly solve for the value of x. Okay, first let's transfer this plus x to the other side of the equation. So we are going to have 2x is equal to minus x plus 5. Now let's divide through by 2 to the power of x. Okay, so we have 2 to the power of x divided by 2 to the power of x is equal to minus 5 plus 5 minus x plus 5 divided by 2 to the power of x. Okay, this will divide this, so we have 1 is equal to minus x plus 5. All right, now this is same thing as this side is same thing as minus x plus 5 multiplied by 1 over 2 to the power of x, right? And 1 over x is equal to x to the power of minus 1. So we can bring this up and say that this is 2 multiplied by 2 to the power of minus x. All right, now permit me to bring this to this side and this one to this side. So I'm going to write now that minus x plus 5 raised to the power of 2 minus x, okay, is equal to 1. All right, now if you are planning to solve this using your algebra identity or your knowledge of algebra, trust me, this is not going to work. So we are going to look at a particular function called the Lambert W function, and the Lambert W function states that when you have a function in this form, e, say a multiplied by e to the power of a, all right? When you have something like this and you introduce the Lambert W function, that this is equal to a. Okay, so what we are going to do right now is to try to manipulate what we have here, so that we are going to have the same thing here and here, and we are going to introduce e to the whole thing. All right, so the only way to do that is to try to make, we already have something like this here, right? So let's also have exactly this as our numerator, as our power, sorry, and that means we are going to add 5 to this power. Okay, but we cannot just add 5 to this power, we're also going to do the same thing here. And to add 5 to this side of the equation right now is the same thing as saying when you have a to the power of m plus n, this is the same thing as a to the power of m multiplied by a to the power of n. So it simply means that I'm going to multiply this side by what? 2 to the power of what? 5. So that I can now pick one base just like we have here, and I'm going to add. All right, so that is exactly what we are going to do now. So we are going to multiply both sides of the equation by 2 to the power of 5. So this is what we will write now. That's minus x plus 5, okay, raised to the power of, okay, times 2 to the power of minus x. I'm copying this so that you can see it. Yeah, so this is what I'm writing now. So we are going to multiply this by what? 2 to the power of 5. Yeah, is equal to 1 multiplied by 2 to the power of 5. Okay, so we can now write that minus x plus 5, then we are going to pick one base since they are multiplying, right? And we are going to add the powers to have minus x plus 5 is equal to 1 multiplied by 2 to the power of 5. All right, now when you look at this side of the equation, you notice that this place and this place, they are the same thing, but according to the Lambert W function, we need e, and e is not here for now. So how do we introduce that e? It's actually very simple, because when you have e to the power of ln x, this is equal to x. Okay, so that simply means that e to the power of ln 2, okay, is still equal to 2. So all we need to do is we are going to replace these 2 with e to the power of ln 2. So we'll now write minus x plus 5, okay, e to the power of ln 2, that is this 2, now raised to the power of what? Minus x plus 5, that is this one, is equal to 1.25. okay, all right, now we have minus x plus 5 e to the power of Now, when you have these two powers on a number, okay, just like in your indices, yeah, you can bring one inside and take one outside, right? So we can now rewrite this as minus x plus 5, okay, ln 2, okay, is equal to 1 times 2 to the power of 5. This is 2 to the power of 5, sorry. It's same thing as 1 times 32. Okay, now when you look at this side of the equation, this one now, the power has ln 2, but this side don't have ln 2, this side, because according to the Lambert W function, we're supposed to have the same thing here and here. So the difference between ours now is the ln 2. So that simply means that we must multiply through by ln 2, okay? So let's multiply through by ln 2, okay? So we now have ln 2 brackets minus x plus 5, then e to the power of minus x plus 5 ln 2 is equal to 32. All right, now ln 2 as well, because we are multiplying both sides of the equation by ln 2. Now when you look at what we have here now, you notice that we have the same thing here. So this is the perfect time to introduce our Lambert W function, okay? So we go ahead and introduce. So the Lambert W function of this ln 2, all right, brackets minus x plus 5 e to the power of minus x plus 5 ln 2, all right, is equal to the Lambert W function of 32 ln 2. All right, now when you look at what we have here, if I rearrange what we have this side, I'll definitely get the same thing. If I rearrange what we have this side, I'll definitely get the same thing. So if I write the Lambert W function of minus x plus 5 ln 2, then we have e to the power of minus x plus 5 ln 2, all right, is equal to the Lambert W function of 32 ln 2. Okay, now we have the same thing here and the same thing here. So applying the Lambert W function, we are going to get this, right? So we have minus x plus 5 ln 2, all right, is equal to the Lambert W function of 32 ln 2. Now let's divide through by ln 2. Recall that we are looking for the value of x, all right? So this will now divide this, and we are going to have that minus x plus 5 is equal to the Lambert W function of 32 ln 2 divided by ln 2. All right, okay, now we can write that minus x is equal to the Lambert W function of 32 ln 2 divided by ln 2. Then this plus 5 will cross become minus 5, right? So we have minus 5. Okay, but we are not looking for minus x. Remember, we are looking for x. So we can write that x is equal to get x, that means we are multiplying through by minus 1. And when we do that, we are going to have minus the Lambert W function of 32 ln 2 divided by ln 2. Then when minus multiply minus 5, you have plus 5. That means we can, sorry, I don't even know you are not saying this. That means we can now rewrite our x as what? To be equal to, we can write 5 first, then we have minus the Lambert W function of 32 ln 2 divided by ln 2. Now, if you press this, if you calculate this, you are going to get an approximate value of 1.7 something, right? So 1.7 approximately to 1 decimal place. So this is the value of x. Thank you so much for watching and have a lovely day. Bye.